Welcome to a lesson with Dr. Powell. Let's take a look at how we can think about how we can determine if a graph is not planar, and with a few different conditions imposed. Well, let's take a graph G and suppose that it's undirected. And so no arrows between edges, and it's simple. Simple means we're going to, if we have two vertices and an edge between them, there's only one edge between them. Now, if it was directed, actually, this would be okay. That means it's simple. This is equivalent in the undirected case to this type of situation, but we're going to stick to undirected in our graphs. So undirected, simple, and that it has more than one edge, and it's going to be connected, not two connected pieces in the graph, but just one, everything's connected via some path. Okay. And using these ideas, we can show that perhaps something like this is not planar. Okay. So first, we need some facts. First one. If we take, if we think about the faces are kind of like the area between edges when you kind of enclose them in such a way. So, and we're going to think about the degree of a face. The degree of the face is how many edges it touches. And we'll notate that with a D of F. So that's a face there. All right, and if we add them all up, claim is this is exactly twice the number of edges. Well, think about that. I mean, every edge will hit a face on this side and a face on that side. So every edge is counted exactly twice in the sum, in the count. So this is clearly true. We add up all over all the faces. Okay, next, if we take, if we use the idea that given these ideas, each face has to have degree at least 3. And it has to touch at least 3 edges. 2 edges won't work. It'll make these conditions fail, and 1 and 0 also makes those conditions fail. So, and so we get actually that this is greater than or equal to 3 times the number of faces. And so we know 3 times the number of faces is going to be less than or equal to 2 times NE. Now, let's take a look at Euler's characteristic formulae. All right, which is NE minus, or NV, sorry, NV, which is in another video, NV minus NE plus NF is equal to 2. Now let's play with this equation a little bit. We multiply everything by 3. And then let's move the 6 over here on that side. So move that over. The other guys over there. So 3NE minus 3 NF. And then what I'm going to do is I'm going to use this inequality. See this 3NF popping up? So notice if I multiply that by negative, the inequality switches. So I can replace this inequality this way with 3NE minus 2NE. See, I'm using the inequality right here. All right, so that's just going to get NE is less than or equal to that thing right there, 3NV minus 6. So if it's planar, if a graph is planar, it satisfies Euler's characteristic formula. And if it satisfies this formula and these things are satisfied, so this inequality right here is satisfied, then this inequality will be satisfied. And in another video, I will show you how we can use this inequality to show that that is not planar. Thanks for watching.